The National Electrical Code, or NEC, sections 800.33 and 820.33 address the grounding and bonding requirements for community antenna television, commonly known as CATV and telecommunications systems. These sections are crucial for ensuring electrical safety and preventing potential hazards associated with voltage differences between different systems and ground. Specifically, these codes mandate that accessible CATV and telecommunications systems must be connected to the building's grounding electrode system. This requirement is in place to minimize the risk of electrical shock and to provide a common ground reference for all electrical systems within the building. When dealing with multiple buildings on a single property, the application of these codes becomes particularly important. If CATV and telecommunications services are extended from one building to another, the grounding requirements must be met at each building. This means that the CATV and telecommunications cables entering the second building must be bonded to the grounding electrode system of the building. The purpose of this bonding is to ensure that both buildings are at the same electrical potential, which helps to prevent dangerous voltage differences from developing between the systems. Let's consider a scenario where a property has two buildings. Building 1 is served by CATV and telecommunications utilities, and these services are properly bonded to the grounding electrode conductor, or GEC, of Building 1. Now, the CATV and telecommunications lines are run underground from Building 1 to Building 2, but the utility companies are not involved in this extension. In this situation, the NEC requires that the CATV and telecommunications cables be bonded to the grounding electrode system of Building 2. This is because Building 2 is now receiving these services, and it must have its own grounding connection to ensure safety and code compliant. If the CATV and telecommunications systems are not bonded to the grounding electrode system at Building 2, a potential difference could exist between the two buildings. This could create a shock hazard for anyone who comes into contact with both systems simultaneously. Furthermore, the lack of proper grounding can also lead to equipment damage and signal degradation. In the given scenario, an electrician has run a 3-wire feeder without a ground conductor to Building 2 from Building 1. The electrician argues that because the CATV and telecommunications systems are not bonded at Building 2, the 3-wire system is acceptable. However, this is not compliant with the NEC. The code requires that all separately derived systems, such as a feeder supplying power to a separate building, must have a grounding electrode conductor installed with the feeder conductors. This grounding electrode conductor must be connected to a grounding electrode system at the second building. The CATV and telecommunications systems must then be bonded to this grounding electrode system. Therefore, the electrician must run a grounding electrode conductor with the feeder conductors to Building 2 and then bond the CATV and telecommunications systems to the grounding electrode at Building 2. This will ensure that both buildings are at the same electrical potential and that the CATV and telecommunications systems are properly grounded. It's important to understand the specific requirements outlined in NEC sections 800.33 and 820.33. These sections provide detailed information on how to properly ground and bond CATV and telecommunications systems. In general, the grounding electrode system should consist of a ground rod, a metal water pipe, or other approved grounding electrode. The grounding electrode conductor should be sized according to the requirements of the NEC, and it should be securely connected to the grounding electrode and the CATV and telecommunications systems. It is also important to ensure that all connections are properly made and that they are protected from corrosion. Regular inspections and maintenance of the grounding system are essential to ensure that it remains effective over time. If any problems are detected, they should be corrected immediately to prevent potential hazards. Now, let's delve into some specific aspects of NEC sections 800.33 and 820.33. NEC section 800.33 covers the grounding of communications circuits, which includes telephone and data communication systems. This section requires that communications cables entering a building be grounded as close as practicable to the point of entrance. The grounding conductor must be connected to the building's grounding electrode system. The size of the grounding conductor is determined by the size of the communications cable, and it must meet the minimum requirements specified in the NEC. NEC Section 820.33 covers the grounding of coaxial cable, which is commonly used for CATV systems. This section also requires that coaxial cables entering a building be grounded as close as practicable to the point of entrance. The grounding conductor must be connected to the building's grounding electrode system, and it must be sized according to the requirements of the NEC. In addition to the general grounding requirements, both NEC sections 800.33 and 820.33 address the bonding of communications and coaxial cable shields. The shields of these cables must be bonded to the grounding electrode system to provide a low impedance path for fault currents. This bonding helps to prevent voltage differences between the cable shield and the grounding system, which can reduce the risk of electrical shock and equipment damage. When installing CATV and telecommunications systems in multiple buildings, it is important to consider the potential for ground loops. A ground loop occurs when there are multiple ground paths between two buildings, which can create circulating currents. These circulating currents can cause interference with the CATV and telecommunications signals, and they can also create a shock hazard. To prevent ground loops, it is important to ensure that there is only one grounding path between the two buildings. This can be achieved by using a single grounding electrode system for both buildings, or by installing isolation devices in the CATV and telecommunications cables. Isolation devices, such as ground loop isolators, can block the flow of circulating currents while still allowing the signals to pass through. These devices are commonly used in CATV and telecommunications systems to prevent ground loops and to improve signal quality. In summary, NEC sections 800.33 and 820.33 provide detailed requirements for the grounding and bonding of CATV and telecommunications systems. These requirements are essential for ensuring electrical safety, preventing equipment damage, and maintaining signal quality. When installing these systems in multiple buildings, it is important to follow the NEC guidelines and to take steps to prevent ground loops. By adhering to these requirements, you can ensure that the CATV and telecommunications systems are properly grounded and bonded, and that they operate safely and reliably. Now let's talk about the specific steps that should be taken in this particular situation. Firstly, a qualified electrician should be consulted to assess the existing electrical system and to determine the best way to bring it into compliance with the NEC. Secondly, a grounding electrode system should be installed at Building 2, if one does not already exist. This grounding electrode system should consist of a ground rod, a metal water pipe, or other approved grounding electrode. Thirdly, a grounding electrode conductor should be run from the grounding electrode system to the main electrical panel in Building 2. This grounding electrode conductor should be sized according to the requirements of the NEC. Fourthly, the CATV and telecommunications cables entering Building 2 should be bonded to the grounding electrode conductor. This bonding should be done as close as practicable to the point of entrance. Fifthly, the shields of the CATV and telecommunications cables should be bonded to the grounding electrode system. This bonding should be done at both ends of the cables. Sixthly, the electrician should verify that there are no ground loops between the two buildings. If ground loops are present, they should be corrected by installing isolation devices in the CATV and telecommunications cables. Seventhly, the entire electrical system should be inspected and tested to ensure that it is functioning properly and that it meets all applicable codes and standards. In addition to these specific steps, it is also important to consider the overall design of the electrical system. The electrical system should be designed to minimize the potential for voltage differences between different systems and ground. This can be achieved by using a common grounding electrode system for all electrical systems, and by bonding all metal parts of the electrical system together. The electrical system should also be designed to protect against overvoltages and surges. This can be achieved by installing surge protective devices at the main electrical panel and at other critical locations. Surge protective devices can help to protect sensitive electronic equipment from damage caused by overvoltages and surges. It is also important to ensure that the electrical system is properly maintained. Regular inspections and maintenance can help to identify and correct potential problems before they become serious. The electrical system should be inspected at least once a year, and any necessary repair should be made promptly. In conclusion, the grounding and bonding of CATV and telecommunications systems are critical for ensuring electrical safety and preventing potential hazards. NEC sections 800.33 and 820.33 provide detailed requirements for these systems, and it is important to follow these requirements carefully. When installing CATV and telecommunications systems in multiple buildings, it is important to consider the potential for ground loops and to take steps to prevent them. By adhering to the NEC guidelines and by following these best practices, you can ensure that the CATV and telecommunications systems are properly grounded and bonded, and that they operate safely and reliably. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work for you. A qualified electrician will be able to assess the existing electrical system, identify any potential hazards, and make the necessary repairs or modifications to bring the system into compliance with the NEC. They will also be able to ensure that the work is performed safely and that it meets all applicable codes and standards. Furthermore, it is important to consult with the local authorities to determine if any permits are required for the electrical work. In many jurisdictions, a permit is required for any electrical work that involves the installation, modification, or repair of electrical systems. Obtaining a permit ensures that the work is inspected by a qualified electrical inspector who can verify that it meets all applicable codes and standards. Failing to obtain a permit can result in fines, penalties, and even legal action. Therefore, it is always best to check with the local authorities before starting any electrical work to determine if a permit is required. By following these steps, you can ensure that the electrical work is performed safely, legally, and in compliance with all applicable codes and standards. This will help to protect yourself, your family, and your property from potential electrical hazards. The correct interpretation and application of the NEC is essential for ensuring the safety and reliability of electrical systems. It is a complex and ever-evolving document, and it requires careful study and understanding. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address emerging safety concerns. It is important to stay up to date with the latest edition of the NEC and to consult with qualified professionals when necessary to ensure that electrical systems are installed and maintained in accordance with the code. The information provided here is intended for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician for all electrical work. The electrician will be able to assess the specific circumstances of your situation and to provide you with the best possible advice and recommendations. They will also be able to perform the electrical work safely and in compliance with all applicable codes and standards. By working with a qualified electrician, you can ensure that your electrical system is safe, reliable, and compliant with the NEC. This will give you peace of mind knowing that you have taken the necessary steps to protect yourself, your family, and your property from potential electrical hazards.